Okay, so solving simple equations. This time, equations with multiplication and division. So multiplication and division are inverse operations of one another. I say opposite, which is a simpler term, but multiplication can be reversed with division, and division can be undone with multiplication, and vice versa. So the first example, we'll say y divided by 4 equals -7. So again, it says we're solving, so we're going to try to get y all by itself. If I would have said solve up here. And solve means we're trying to find the value of y, kind of like solving the puzzle. So again, y needs to go from y over 4 to just y. So that means the 4 is no longer there. So the opposite operation of what's happening here, I see this is division, so the inverse operation would be to multiply by 4, because the opposite of dividing, the inverse operation of division, is multiplication. Now, this kind of looks like a fraction, so just to be fair, I'm going to put a 1 over there. And there's two ways to do this. You can go ahead and cancel this diagonally, and the 4's are now gone, and you're left with y over 1. Or you can go multiply straight across and get 4y over 4. So either way, you'll get the same answer. So let me show you what that looks like. On the top, I'll do 4y, multiplying straight across, times 4. That's the first option. Or I could just cancel these and get y over 1. That's the second option. Those two actually represent the same thing, because 4 divided by 4 is a 1y, and any number divided by 1 is still 1. So you get the same answer regardless, if you want to cancel them first or multiply straight across, but I know that the final answer is going to be 1. And on this side, what I do to one side, I do to the other. Now I noticed this looks like a whole number multiplied by a fraction, but I really didn't need the 1, so just so that it looked like the other side. -7 times 4 is -28. And if you put the 1 over there, it didn't matter, but it's the 1. And so there, you're done. This 1y is the same as y, right? I can say, give me 1 apple or give me an apple. So if you see a y, it's the same as 1y. So you don't need to say specifically how many. You already mean there's a y there. You know it's just 1 y. The next one. Like I tell students, and you never say, Miss Flores, can I borrow 1 pencil, right? You just say, can I borrow a pencil? So if you see a y, there's only 1 y there. So we need to put the 1 there. The next one is -3/4 n equals -2. Now, this one requires a rule that we need to remember, because this actually looks like multiplication of a fraction. And when you have multiplication of a fraction, dividing by a fraction gets a little bit crazy. So one thing I need to remember is a sidebar. So let's make a side note. So I'll just do it. One thing you need to recall is what reciprocals are. A reciprocal is anytime you have an original fraction multiplied by the inverted fraction. You get 1. And that always works. So let's say I have 7 over 11. The reciprocal would be 11 over 7, which equals 77 over 77, which equals 1. So no matter what, every single time you multiply the reciprocal and an original fraction, you will get 1. So that's the beauty of reciprocals. It'll give you a 1 when you use them. So in this case, I do know that I want an invisible 1 here. So I'm going to use the reciprocal to convert this -3/4 into an invisible 1. So I'm going to multiply by, squeeze it in here, 4/3, and that's got to be negative. And what you do to one side, I have to do to the other. So now I'm going to do my fraction multiplication. Negative 4 times negative 3 is 12. And 3 times 4 is 12. And that's still n. And on this side, I can put a 1 under here, so I can go straight across now. Negative 2 times negative 4 is positive 8 over 3. You could also cancel the 3 here, cancel the 4 there, which gives us an invisible 1. So this 12 over 12 is an invisible 1 in disguise. And that invisible 1 is what we wanted, so n is now all alone. And this is an improper fraction, so 3 fits into 8 2 times, and that fits 2 remainder. So your answer would be n equals 2 and 2/3. Alright. Now, let me show you what this would have looked like, because some people will say this is being multiplied by 3/4. Little side note. If you see this as, Ms. Flores, this is multiplied by 3/4, so don't we divide by 3/4? Yes, you're right, you can do that, but it'll look like this. And that just looks really strange because you have a fraction in a fraction using division bar, and even if you don't use the division bar, it would look like you can even write it like this. So this is just a lot of steps. So the reciprocal would be the best way to do it. Anytime you want to get rid of an entire fraction, just multiply by the reciprocal. It's better than trying to reverse this multiplication and dividing by a fraction. Alright, now on to the third one. Pi times x equals 3 pi. Now, it looks like there's more than one variable there, but the only variable is x. Pi, again, is a number. So this is a number times x, and that number happened to be pi. I put the dot there because I know it's multiplication. So once you see the operation that's there, you do the inverse operation, which is to divide by that number, which happens to be pi. When you have the same number divided by the same number, that's going to be an invisible 1, x. And on this side, pi divided by pi, that part will cancel, and you're left with 3. So it's actually multiplied there, so you have a 1 and a 1, which is invisible. And so x equals 3. And the fourth example of simple equation, 3p equals negative 2/3. Alright, so you want to get p all by itself. There's a number next to it. And that operation, I observed it as a multiplication. Since it's multiplication, the inverse operation is to divide by 3. Now, I can put division of 3 here, but it'll look like a fraction inside of another fraction. So instead of using the division bar, I'm going to use a division sign. And then I can put a 1 under here. So p equals. Now, there are rules for dividing fractions, and some of people think of it as a little trick. Multiplying by the reciprocal, which is what we did in the first example, or it's something that sounds like keep, switch, flip. You've probably heard that before. You keep the first one, you switch the sign, and you flip the third fraction. So you keep this one the same, switch to multiplication, and you flip it to 1/3. So technically, when you're dividing by a second fraction, you are really multiplying by the reciprocal, which is the flipped version of the fraction. So now we're going to multiply straight across. That's the rules of fractions. 3 times 3 is 9, and negative 2 times 1 is negative 2. So your answer is negative 2 over 9. Alright. Now let me show you the difference between these two problems. This one had an entire fraction multiplied. This one was just a number being multiplied. So when it's just a number being multiplied, it is